graphing calculator. So go ahead and grab one of these. Hopefully maybe it still has the function from yesterday, potentially.
This one isn't for you, it's for me.
And there are some dead.
So we left off graphing the circle. Right, so we had...
I'm petty enough to learn that actually use my calculator.
I don't know if I can hear that shadow.
This has made me hate circles.
So we were in our y equals, and we had graphed this, because we had solved out that for a circle centered at the origin with a radius of 4, it comes out to give us a graph like this. If we wanted to zoom square it, and make it look more like a circle, we can z-square. Z-square. And it makes my units the same amount of pixels on the screen, as opposed to a widescreen resolution where your pixels stretch objects. Like this is normally defaulting to the 10 by 10. This is actually like a 20, or no, not 20, it's like 14. I forget how wide it is.
15.16.
15?
It's like 15.16.
Yeah, so now instead of being 10 wide to the left, it's 15. So this has now made this like a 30, a little over 30 by 10, I believe. So we asked, now why has the circle disappeared there? Near the axis. Now what? So we typed in two things in the y equals. What do we call the things that we put in our y equals? When we graph, we're graphing, what do we call them? We can sometimes use f of x to represent blank notation. A what?
Function.
A function. And one of the base principles of a function is vertical line test. What does the vertical line test tell us? Right?
Oh, that no input has the same output, but the other way around. It's one of those.
No two inputs have the same output, or no two outputs have the same input.
One of those.
If you draw a vertical, let's say you hit something twice, your function like this.
Okay.
Say that's not a function. So this is going to be the same input has two different outputs. So two outputs sharing an input, not one. Two outputs sharing an input, not one. So sometimes on your calculator, depending on how zoomed in you are, it stops when it thinks the line is going to get vertical or when it's going to show the line looking vertical. But also one reason it does this is your ticks on the line. It's not showing that so that it can show you the line. So let's take a second. Yeah?
Whenever I try to click graph, it always says invalid DIM.
Did you make sure that you're using a negative, not a minus?
Yeah. It's probably just that.
Yep. Your stat plot's on. You gotta turn it off. They're arguing. You can't do both at the same time.
Okay, thank you.
You're welcome. So go to your notes at the bottom of the front page there. Let's graph this circle. So you can either turn off the graphs of the circle that we had or clear them. I don't care which you decide to do. So we are going to type these two functions. And notice that they both start with 3, but then we have the plus or minus. So actually you only really need one of them, and then you just change it to a minus. So I'm going to leave these two, actually. So I'm going to turn those off. And now I'm going to put my new ones into y3, y4. So I've got 3 plus radical 16 minus the quantity, x plus 4, close parentheses squared, close your parentheses for the radical. Do not forget to check, do I have as many parentheses closed as I have open? And now we wish we could copy paste, and there might be a function to copy. Hey, Estes, do you know if there's a way to copy paste on a TI-83?
Oh, yeah, I think so.
Right? Wouldn't you think that there would be a way?
I think there is.
Because I want to copy function y3 and just paste it here, but make that a minus.
Yeah.
That would be fun.
Yeah.
So homework for the weekend: somebody figure out how to copy paste on a TI.
Yeah, somebody just Google that.
I mean, yeah, you can do it right now if you want, but you're gonna fall behind if you don't keep up with us.
I have a
So
question.
you got
Or you have.
okay, hopefully. So we type in those two functions.
Wait, I need two functions.
My question is, why is the cap?
It's on your pool.
The functions are on your notes, right here. These, right at the bottom of the front. So why the gap? Right? Does that gap actually exist? If I'm trying to work us to you guys kind of figuring out why this happens. If I Z-box it, you can do whatever Zoom technique you want right now to try to figure this out, why that gap is happening. If I Z-box that, and then what if I Z square after I Z box? Let's try that.
Maybe the two ends just don't match each other, so they're trying to stay away.
I wish I could. Ooh, maybe I can. Yeah. Look at, now this is really bad, and it's really green because it's mad at me. Right here, in your calculator, and I always go back to, your calculator is really quite stupid. It knows how to do what we tell it how to do, but aside from that, it can't think, right? Our computers these days we're starting to work in AI where it can solve problems that it encounters. This is encountering a problem. You've typed in two functions that are functions. They're real functions. We typed them in. They exist. They satisfy all of our function rules. There is a connection between here. But in your calculator, at that point, it thinks, based on the sizing, that that's a vertical line. Like, it's going to show it on the same pixels. Not that the line's actually vertical, but it'll show it on the same pixels, which breaks the function rule. That gap doesn't actually exist there. This is a full circle. That is just your calculator having an issue representing what it's trying to show you. Yeah. Yeah, I need to pick that up when I don't. Kids, that fell off the shelf. I would prefer you not to because you could cut yourself and I would rather not deal with that. But you could just not touch it. That would be perfect. So, know that that gap isn't actually a gap. That is just your calculator having issues showing you what it's trying to. Any issues with that? Any questions? It's just having a moment, if you want to say, or whatever. It's trying to graph your functions. It is doing a pretty good job on the top part and the bottom part, but where it reaches that this, because if you look at this output,
Mine doesn't have it.
I know, because your calculator's smarter.
No, this one.
Do you have it in squared?
Yeah. Well, I have it.
He said
Like, I'm not sure if you guys
sometimes. Jack, so saying graph, so again.
You still have a gap. Look at it. It's because of how you manipulated your zoom. So as you play with your zoom and change your window features, you can kind of get rid of the gap because the issue, why it's creating the gap is it's trying to represent those on the same pixels, which would not be a correct representation. It is not a vertical line, and that's why it is not showing it, because it is stopping itself from misrepresenting it. So Caleb's window has been a bit modified, and he's got a much smaller gap. Yours is probably only like 2 pixels. But there's still a tiny little break between them because the calculator just can't show it. And we could do an output table if you're curious about this. For what my input, I need to make my table ask. So for what values work, like when x is -2, where my y's are, when x is -3 or -4. And we actually know that this center, or this circle is centered at -4, +3. So if I type in -4, that is my center point. So the top of my circle is at 7. The bottom of my circle is at -1. that tells me my diameter is 8. So if my diameter is 8 and my center is at -4, what if I go out 4 to the left to get to that left edge? So if I go to -8, what it can't show is in your graph, that -8, +3 is right here. It's not showing that because it's confusing itself. But when I type in -8, I can see I have the same output values. And that's why it's having an issue showing it on the graph. Because it creates what it thinks is a vertical line, which would break the rules. So it's the issue with your calculator is not as smart as you actually are. We know that this actually graphs the full circle. Yeah.
I think I got rid of the gap.
How'd you do it?
So I set my window
Yeah, it's all about window
to
manipulation.
like -18 and then 2
We don't have to get rid of the gap.
and then -2 and 18. And then I graphed it and it was oval, so
Z-squared.
yeah. And then it's kind of wonky,
So-
but there's no gap.
Here's what you've actually done. You have zoomed out. The more you zoom out, the less that you would see the gap. The more that you zoom in, the more that you would see the gap, because there's less pixels, or what am I trying to say? There's more pixels able to represent a smaller object. So when I try to use more pixels to represent like a bigger object, when I zoom in, that I'm too close and my line looks vertical. When I zoom out, I can better represent it. So if I zoom box on that and zoom back in, that gap will still be
But
there.
it's the same. I just shifted it over.
No, your window's got a bigger distance in it.
It's still 20 by 20.
But our other one wasn't 20 by 20. Our other one was 30 by 20.
Well, but even with the oval,
So you
Like
zoomed
before
out,
we-
essentially. Watch. If I zoom in, I guess I can see box. Yeah, yay.
this is still 30 by 20.
But then we zoomed in, and that's when the gaps show. Is when we zoom in.
Well, but why did it show the gap before, but not now?
Because this just goes back to the fact that your calculator, every time it runs this, if it encounters an issue, it doesn't show the gap. Now, it's not showing the gap because it's kind of figured itself out, I guess. Or, I mean, it's just a calculator issue. So we don't need to spend more time on this. All you got to understand is if it looks like there's a gap, there's not. There's not a gap between those two functions. They perfectly meet up. They perfectly make a circle. Can we all agree on that? It's just calculator issues. Sometimes it'll have a gap. Sometimes it won't. It all depends on how your calculator figures out that issue. But it comes down to the ratio of the pixels. That's where the issue is.
Bless you.
So actually, I think if I zoom square again. So let's think about the got it. Our next problem in the notes here, while my calculator loads forever. If we need to write the equation of a circle with center 5, -2, and radius 8, let's start with our original equation. So our original equation, as we have up on the start slide, if you want reference to that, is that we're going to have x minus the horizontal plus y minus the vertical.
And you don't want us to remember this?
I mean, as you use it more and more, you will.
Do we need to do that?
Probably.
It'll probably be on your function sheet. If you're talking about for like state testing and that sort of stuff, that this is normally one of the functions on the sheet.
Wait, do we have to measure like
As we get closer to testing, I'll give you guys one of the function sheets so you know what's on and what's not. And you can look it up right now if you want. Like you can Google 8th grade air formula sheet or whatever you want to call it. So when we go to type this in, or when we go to plug in our values, what are my h and my k? Caleb?
The h is going to be 5. Well, -5, I guess.
Well, so h is 5. So when I set this up, it's going to be x minus 5.
And then your k would be -6.
So that's going to end up being y plus 2. This is where people make their mistakes. So we have x minus 5 squared plus y plus 2 squared equals my 8 squared. Now we manipulate. Bring this to the other side by subtracting the entire thing. That will give me y plus 2 squared equals, what's 8 squared?
64.
64. Minus x minus 5 squared. What's that? What can I go ahead and do? Well, okay, we don't need to. We could square this if we wanted to. Like, we could square a binomial, FOIL it out. Brian?
You like square root everything?
Yeah, so if I don't square this, which it's up to you, it's all what do you want to type in your calculator. If I leave that how it is, we can square root the whole thing to get rid of this square. So that becomes y plus 2 equals,
8.
No, right, because we can't take it out.
don't
Oh, yeah.
break it
I knew that.
apart. You can only break it apart when it's multiplying or dividing.
I'm always getting that.
So this stays together. So when I get the y by itself, always remember that you've actually created two answers. When you square root, at that moment, you've created two answers. So now, when I subtract the 2 from both sides, that minus 2 is the only thing that doesn't have two answers, or like a positive and a negative. So we have minus 2, or negative 2 plus the 64 minus yada yada, and then we have the same thing minus this radical 64. So I'm wondering, is there a way that we could more easily write the equation of a circle? If we want to write like a y equals form. Yeah.
Why wouldn't you take the square out from the x minus 5 squared? Would you do anything to that?
Because we can't break it apart. That x minus 5 squared is attached to the 64
Oh,
through subtraction, which is not an operation that we can manipulate using the square root.
Alright.
Calvin?
I got the equation.
You have a proposal for our equation?
The formula, yeah.
So, by the way, my z squared took so long that it turned itself off. Minimize that for now. Capture this. So let's hypothesize what equation in general form could work for any time. Anyone missing a flash drive cover? So if we want to hypothesize, we could say y could equal, what do you got?
K plus or minus the square root of r squared minus the quantity x minus h squared.
Did you just put R for instead of R squared?
No, because we can't break them up. Because you cannot. You're thinking about if this was r squared times x minus h squared, and we could, when we do the square root of that, break them up into square root of r squared and square root of this. We can't do that with the subtraction. So we just keep it together as one polynomial, or one polynomial. So let's check this. Would this have worked up here? Well, their HK was -4, 3, and their radius was 4. They end up with the equation. So we said they had -4, 3, right, and a radius of 4. So their k, 3 up front, plus or minus, there are two options. R squared, well, if their radius is 4, we get 16. Minus the x minus h, well, minus a negative 4 would be the plus 4 squared. This, if you want to jump right to it, is the y equals equation of a circle.
When I did this problem, I ended up with y equals 5 minus x.
Good morning, Maya Grissett. Please
You
come to the
can't take
office.
the square
Maya
roots
Grissett
of
to the
those
office,
values.
please. Thank you.
So do you have the work right now?
Yeah.
Hold on. Don't press that.
That's it's on the outside. So I just squared it in this one.
You can't. Because you can't square root two things. If this was multiplied together, then you could square root that and square root that. But since these are added together, you cannot do that. So you're breaking a match rule begins. So here's the rule that we're coming back to. You guys essentially have the square root of something being added together. Right? So you have like x plus h and y minus k, or x minus h and x minus k. And you're trying to say, like some of you are trying to say, well, we can do this. Well, this is 16. Square root of 16 is 4. If I square root 5 and I square root 11, this does not work. We cannot do this. We're not allowed because of the addition. If these were multiplied, this would be different, and we could. But we cannot do this. So, please remember that when you're starting here, this is what Ethan just said, well, I square rooted the whole thing, so I square rooted that, square rooted that, square rooted that. It does not work. You cannot do that because these are added. Cool? A little bit too zoomed in, I feel like. Alright, so using translations. So we know the standard form of our equation. And we know that there's a center and a radius. The reason that this works, by the way, to go back to like what's actually happening. When you look at a shift from the origin, and you look at the equation that we're dealing with, all we're doing is making right triangles. Because when you look at plugging in that h and plugging in that k, what you're plugging in is how far over have we gone for an h, how far up have we gone for a k, and then that has to equidistant out regardless of what direction you look. So when you play with input values, you start to see this works because of triangles. We're making right triangles here. Like a squared plus b squared equals c squared. This is kind of a manipulation of Pythagorean. Kind of. No. Not yet. Fine. Do it. Now it's math. They switched it when they updated the software. Clearing used to be the second choice. The first choice. I get confused. So when we look at an equation, we have an equation x squared plus y squared equals 9. And we want to shift it 4 units left and 3 units up. So we're moving where the center is. Excuse me. So I have this all plugged in. This one's done out for you. So when we manipulate our equation, all we do is adjust my x minus h, because now I have an h, and my y minus k, now I have a k, well, my radius has not changed. So it still equals 9. And I set it up. I can manipulate this into the y equals form if we want, but that's going to be what we get here on the graph. We get the translation that we were shooting for. So, try our got it. Ooh, too far. if we want to translate 5 left and 3 down, where is that going to make our center?
You want us to put it like y equals 1?
Sorry, the guys that work with me at Lifetime are. Do you guys hear about the carjacking that happened at Lifetime?
No.
Which is pretty rare because it's doubling. So Lifetime up there on Sawmill. Somebody, I haven't read the story yet because they just sent it out, but I don't know if they, like, their car just got robbed or if they literally, like, they were in the car and somebody walked up and they had to get out of the car. Either way, you have insurance for a reason. That ever happens to you guys, get out of the car. Give them the car. Possessions are not worth
Life.
really, yeah. Just give them what they want. The cops will catch them eventually. They already caught people. So, when we shift 5 units less than 3 of this down, where, then, is my center? Okay, so, it's -5, -3. So when I go to build my equation, what do I have? Ryan?
X equals 5, plus 5, my bad. And then y plus 2
Oh, sorry. 3
equals 3.
equals what?
Uno. That's 1 and 2.
Oh man, thanks for dropping that knowledge.
Dang.
That was already our radius squared. My radius has not changed. All we've done is shift it. Now, if we wanted to make it into the y equals, we said, because the more we use it, the easier it gets. What was our equation?
It was y plus or minus radical r squared minus parenthesis x minus h.
So, here, remember HK, so this is -3 plus or minus radical 1 minus x plus 5 squared. That would graph my circle. Any questions? So, the whole graphing a smiley face situation, I need to remember when we're done with this class. I think it's shorter today. That schedule's not right anymore. Because we took time from all the classes.
Ooh, it's
No, that's from lunch.
it's 50.
You have the Friday grade option schedule?
Yeah.
Well, no, but it's just everything gets shifted.
One class
One
forward
class
and then
before
foundation.
because
I-
And lunch.
I'll show you guys what I'm talking about in a second.
No, but
So-
what
No,
he's
it's
saying
just
is
one
Friday creative start is longer, but they take time out.
Yeah,
of
it
it.
took
And
time out of all
lunch.
classes. No, they just had a lunch in there. No, in the first class. No,
The
No,
Mr. Allen literally.
Here's
said-
what
Yeah,
happens,
that's
guys.
Foundations is naturally shorter.
Oh, no.
The first time we rolled a Friday creative option, the first day we did it, we only took time from lunches. We then decided it needed even more time, and we took time from classes. So there is a new modified schedule. So try this for a second. Check this out. I'm going to pull up my email just to check the schedule.
Why couldn't you do it like you did last year?
Let's go, go, go.
All right. So, if we have a plot of land, and actually this is, who knows, one of you guys may, or multiple of you may end up being surveyors. So surveyors plot land and you never know what you're going to end up doing. Surveyors plot out people's property lines, right? So they're the guys with the tripods out there with cameras and spinning little laser things, tracking like where are certain things, and they normally have spray paint. So we say that the center of this field is at 450, 500, and its radius is 400 feet. Which makes sense because if your property edge is like 0, 0, you probably want a little bit of space between the property. Sometimes we have circular fields because of the type of that and equipment that we have that sometimes they run in circles. Yeah, Carmen was all about this.
No. My grandpa's fields are all like.
Well, they're all square because of the equipment that you guys have. So if these are both positive, which equation up here is going to model that circle. It would graph that circle. Michelle? Because when we square my radius, we get 160. Any questions on that? I need to restart my computer. When it stops, like not right now, but when it stops capturing, I have to walk over and use the mouse. It just means I need to restart the computer.
I thought you said you were restarting.
Yeah, I was about to say.
I was about to say that's fine.
No, that'll take like 10 minutes. That would be the rest of the
That's
class.
fine. You can just
What
take all
is the
time.
equation? Now we want to put it in the standard circle form and in our y equals form. So radius of 12, center of 7, negative 10. Because honestly, if you can remember the quadratic equation, the quadratic formula, you can remember this. It's not that complicated.
But there's no song.
You could try to make one.
Y equals k plus or minus square root r squared minus.
You gotta choose a tune that could work.
Oh, dear, no.
I think David's song is better.
That was soothing. Wasn't
Emma,
it?
do you have the standard equation that we would use here?
X minus 7 squared plus y plus 10 squared equals 140.
That's what I got.
Really?
And our other equation would be our y equals.
Oh.
Go ahead, sure.
And plus or minus the square root. 144 minus x minus 7 squared.
And then in a calculator, you
No.
use
The parentheses go.
Sorry,
on the
I
other
just
side
drew it
of
in the wrong place. I wasn't even trying to do that on purpose.
Y equals regular k plus or minus the square root of r squared minus quantity of x minus h squared.
Kinda works.
That was impressive.
I like mine better.
David, yours was so. Yours was just like. Y equals.
Alright, continuing onward. If we need to find information when given equations or information about this. And this is one of those, it's hard for me to show you how this is going to be applicable in your lives because I don't have the stuff that you guys might end up doing. But when you get into modeling programs and CAD, like computer-aided design, all those sort of things use programming that involves functions such as this. So a lot of design uses circles and round objects and things like that. So there is a lot of application to this. It's just hard for me to show you like in the technical side of what you're going to be doing. Because 10 years from now, when you guys are out in the professional world, the whole world will be different than it is right now. Like 10 years is a vast change in technology. So if we're trying to find the center and radius, and we have the standard form, we just kind of work our way backwards, and we say if h is 16 and k is negative 9, that's my center. And the radius, we square root that right-hand side, and we get our radius. Now, this is given to us like this, though.
Oh, very nice.
That's hard.
That's not very nice, you said?
They're mean.
What?
Wait.
Hmm?
Could you like double factor at the same time?
Could you double factor the same time? What do you mean?
Like factor the x and the y at the same time.
So remember, factoring doesn't change anything, right? I'm just manipulating. So if I factor something out, I haven't technically changed anything, I just rewrite it. So, do you want to move anything around first?
Yes.
Or, okay, what do you think we want to move around?
Put the x's next to each other and then the y's.
Got it. Minus 10y. All I did was
No,
rearrange.
I'm not talking about that.
All I did was rearrange.
Oh, I get that. No, I get that.
So, hold on. So you were talking about can we double factor? Now, the only thing that I could factor out of these would be an x, and I don't really want to factor out an
I
x.
forgot about adding a constant.
So what I could do,
Wow.
I need to get to a perfect square.
That's what I was thinking.
So what we actually have to do is complete the square twice.
That's so
So
much better.
if you were given this as your equation, we want to figure out if I have x. I don't like doing that in red. Red is like my real dramatic color. Let's do green. I want this to be x plus something squared, y plus something squared, and something squared. To get to that perfect square, x plus something squared, well, to have the b value of 8x, what would this need to be? 4, which would tell me that I actually have another constant value somewhere of a 16.
What's that one
Negative
equation?
pi.
It's half of your b,
That's it?
and then
Square?
you square it to find your c
B
value.
squared, yeah.
Half of b squared is your c value.
Well,
So then for y,
technically, it's 1/2 b squared over a.
then we have an a of 1. We don't get that evil yet.
Okay.
If you have a coefficient on your x squared or your y squared, that would be very bad. I think that's more math 3. I don't even know if we get into that this year. So then, if this was a minus 10, Michelle?
That's right. It's 1 minus 1.
Ah, this would have to be a negative 5. I'm going to rewrite all this. And this would actually then, if I squared the negative 5, have a constant value of 25 over there. So, sorry that I wrote this like this. I'm just kind of at the bottom of my screen. What's really happening is in between here, we're looking at a step where we have x squared plus 8x plus 16 plus, it only didn't take half of the plus sign. What is wrong with you? Y squared minus 10y. Sorry. I hate that. I'm a color specific person. I like colors to represent things.
Why'd you say 10y?
Because it was minus 10y over here.
Oh,
But,
yeah,
so hold
yeah,
on.
okay.
So we added in this value and added in this value to my left side. So we also, right,
Add it to 8,
add what?
16, and 25.
What is that together?
41.
41!
Wait, do we
Dang it.
do we add them or subtract? Wait, I know we add them, but
You added to
It's
it.
such a
So we made the
we
equation.
subtract it to the other side and cancel it out.
No,
No,
we have to
you-
do the same
either-
thing on
either
both sides
you
of the equation.
Or you would do the opposite on the same side. That's what you're thinking of.
So, when we look at starting from here, we changed our x's into a trinomial that had to bring in an extra positive 16. The y's had to bring in an extra 25 positive. So my right side, to compensate and keep this balanced, has to bring in an extra 41 positive. Weird.
How come we did like the opposite thing like yesterday for the other problem?
Because if to compensate for an addition of a positive, you can either add the same positive to the other side,
Or subtract.
or add a negative of the same on the same side.
So, here's the other option, Rhea. Instead of adding the 41 here, I could instead, off to the end of this, subtract 41 and say that I never did anything at all. because what I added, I compensated with a subtraction. But if I do that, I don't do this. But the issue is, I don't want anything else on my left-hand side. I want my left-hand side to be in standard form with just the x, like the binomial squared and the binomial squared. Got it? I get excited. I throw things. So these are your two options, but we don't want to take the option where we do anything else on the left-hand side. Now we get here, but I'm going to clean it up because we got to look at it in the right form. We have x plus 4 squared, y minus 5 squared. And this right-hand side
49.
became 49, which is 7 squared. So this tells me that my center,
Equals -4, 5.
-4, positive 5, and a radius of 7.
I did it.
When you all hated me and thought completing the square was the dumbest process ever,
I
and
like
what was
it.
the point?
I did not think that was
This is why that knowledge base is important. This is why circles relate to parabolas. This is where the tie-over happens.
I didn't do that.
I appreciate that.
I don't hate you.
Well, people can momentarily hate me. I just hope in the long run you don't hate me forever. So, any other questions? I didn't even hear that. Any other questions? I seriously missed that I wasn't focused.
What?
So I'm gonna get my basement.
It kind of worked. Maybe. No.
You know what? That's actually kind of funny. There's a song where it talks about the opposite of love is not hate. The opposite of love is indifference. If I hate you, I still have very strong emotions for you, right? The opposite of like loving or caring for somebody is not caring at all. Like if I don't care what happens to that dog or that person or that, you know, see that like immediately you're like, how could you? That's why I own 4 dogs now.
I
Because
saw
I
the
have
dog
empathy
and
and
his name's
Alright, so we're out of time as the 7th grade is busting down my door shows you. We will have to wrap the very last tiny bit of this, but you should be fine to do all your homework. So 12-12, you should be fine to get finished up now. You're going to take questions from chapter 12 next week, and we will take your master at some point finally next week while we're still in February. Thank you.
Yeah.
No, you don't have to walk down.
Can we just hang out too?
Hey, if you want to take a graphing calculator home for the weekend, you're more than welcome to. I just got to that.
I can see myself doing that.
Nah, I'm not certain. I don't want to tell you something and have you quote me. But you can always do it in Desmos. Like, you can get around not having graphing.